All right, Year 9, I'm now going to do a video or a YouTube clip on significant figures. And I'm going to combine it with scientific notation. So if you haven't had a look at the scientific notation video or you don't understand scientific notation, watch it first before you try and jump into this one. So significant figures just tells us the accuracy of a measure. Now some people will say that that's not true, it can relate to any number, but not necessarily so. And if you understand that concept, you're all right. So here are our notes from Google Classroom. The number of significant figures tells you the degree of accuracy to which a measurement has been taken. Now, if you understand that concept, it'll help you be able to move through significant figures quite easily. But if you'd write something that's a little bit less conceptual, if you want some rules to follow, these are the rules. And the only one that you need to worry about when you're deciding whether or not a number is significant is zero. They're the only decisions you have to make. So the first rule, all non-zeros are significant. So a number like 4357, four significant figures, because everyone is significant because you've measured every thousand, every hundred, every tens, and every units. Okay, so there's your first step. If it's not a zero, the number is, or the digit is significant, or the figure. Now, zeros between non-zeros. And now we're getting a little bit complicated, so you've got to understand what zero is and what a non-zero. A zero is just zero, and a non-zero is any other number. So let's think about it. If we look at this, 2017, how many significant figures? Well, four. Well, why is that so? The reason is because I've measured the thousands. I must have measured zero hundreds because I've gone one step further and measured the tens. Remember, it's telling me the degree of accuracy. And because I've then gone to the units, I've measured 4 units or 4 significant figures. And the same happens here. This has 6 because I've measured that one, that one. I must have measured that one because I measured the one after it, and that one and that one. So zeros in between numbers are significant. Now, zeros at the end of a number after a decimal point. Well, they're significant because you don't have to put them there. They don't add place value. So if you write this number, 7.800, well, those 2 zeros at the end don't change the place value. So if someone's taken the time to write them down, it must mean they're significant in some way. It tells you that the person who wrote them down measured to that degree, to 2 more decimal places beyond the last one. So there are 4 significant figures. Here, that 0 at the end does not need to be there. So the only reason it's there is to tell you that this measurement has a degree of accuracy of 0 hundredths. Okay, so if you're ever unsure, your best bet is to say the zeros are significant. But here we go. Here's the only case where zeros are not significant. Zeros before a non-zero, after the decimal point, are not significant. They are only there to give you place value. So if we look at our James Bond number, 0.007, that's a bit more than a James Bond, those first 3 zeros are not, you haven't measured any of them. You didn't go beyond the thousands. The first 3 zeros, no significance. Here, the first 2 zeros, you haven't measured any units, you haven't measured any tenths, but you have measured the hundreds, the thousands, and the tens of thousands. So there are 3 significant figures there. Finally, and I don't think the textbook does this correctly, because zeros at the end of a whole number, well, you don't know. Here's a case you just don't know. They may or they may not be significant. So, for example, take the case where you said that there were 25,000 people at the stadium to watch the sporting event last night. Oh, 25,000. You don't know whether that's accurate to the nearest unit. Were there actually 25,000 people there to the last person? Or did the person decide to round in the tens or in the hundreds or even in the thousands? You don't know. You do know that that 2 and 5 are significant because they're non-zeros. So this number has two significant figures. All right? It has two significant figures, the 2 and the 5. The next three you don't know because you don't know whether they've rounded. So it could have 3, it could have 4, and it could have 5. So they're your rules. So again, what are we going to be doing in class? We're going to be doing 6G. We're just going to have a look at some questions, but then I'm going to show you how to use your calculator. So let's have a look at 6G. And there are their rules. I don't quite like their explanation, their rules. I prefer the ones that we've written above, and hopefully you've written them down in your workbook. So we're just going to go to significant figures, and we're going to say how many numbers are significant. And we're not going to do scientific notation yet. We're just going to do significant figures. So let's look here. How many significant figures are here? Well, the 2, 7 and 2 are significant, and we don't know about the last 2. So there's 3, but there could be 4, and there could be 5. We don't know. In this number, the zeros are between. So those 2 zeros are significant. So there are 4 significant figures there. In this number here, those first 5 numbers are significant. The last 0, we don't know. So it could be 5 or it could be 6. This one here, those 2 numbers are significant, but we don't know about the 0 at the end. So 2 or 3. Here, those zeros at the front are not significant. They're only there to give place value. So there's only 3 significant figures there. The next one, the 2 and the 0, are significant. Because the 0 at the end would only be there if they'd measured it. So there are 2 significant figures there. Here, that 0 at the front is not significant, but the 0 in between the 7 and 6 is. So there are 3 significant figures there. And this one here, how many significant figures? Well, the first 3 zeros are not significant. They're only there to give place value, but the last 3 are. So there are 3. Now, how do we write a number in significant figures? So we're going to go here, and we're going to just do these ones here. If I'm going to write these in significant figures to 3 significant figures, that means I can only have 3 numbers. So I'm going to write 3, 2, and now I have to decide. Oh, sorry, I've drawn that in the wrong spot. I have to decide, and I'm going to make it bigger because now we can't see the number behind. We have to decide whether I'm going to write that as a 4 or a 5. And the number behind is 7, so it's closer to a 5. So I'll make it 5, and then I have to add the other numbers for place value. So I have to add 4 zeros. So there's my 3 significant figures. Here, those first 3 zeros are not significant. I've got a 1, I've got a 0. Now I have to make the decision. Am I going to write a 3 or am I going to write a 4? And the number behind the 3 is a 1, so I'm not going to round. Oops, I'm still in red. So I'm going to make that a 3. And now there's 3 significant figures. Here, that first 0 is not significant. And I'm going to go there. I'm going to write the 1 and the 7. Now, is that number, sorry, I've drawn that line in the wrong spot. Is the number behind that 2 5 or more? No. So we leave it alone. We round, keep it the same. Now, as I go here, I'm going to write 4 significant figures. So I'm going to write 4, 8, 3, and then I stop because I need to have a look at that last number. That 3, I look at the number behind. It's not 5 or more, so I leave it alone. And then I add the 3 zeros for these places for place value. Again, I'm going to do the same here. I'm going to write 4 significant figures. So I'm going to go to there. I'm going to have a look at the number behind, and I'm going to decide, oops, sorry, I've drawn it in the wrong spot again. I'm going to go here, and I have to go, well, the first 2, non-significant, don't worry. The 1, the 4, the 4. Now I have to decide, and I'm going to leave that as a 2, and we're going to round it to a 3. And I look at the number behind, it's 7, so I'm going to write a 3. And the last one, I've got 1 significant figure, so I'm going to go there. But I need to be careful, am I going to round it up or leave it alone? So the first 3, 4.000. Now I have to decide, what's the number behind that? It's 0, so I'm just going to write a 1. Now here's the key. Most of the time you're going to be able to do this by calculator, and you're going to be able to do it in scientific notation, which is fair enough. So let's just have a look at this one, which we've already done. If I was to write that in scientific notation, I'd write 3.25 times 10, and how many decimal places are there? 1, 2, 3, 4, 5, 6. Now watch what your calculator does. Your calculator can do scientific notation, all right? But first you have to set it up to be in scientific notation. So you go Shift, Setup, and you see down there number 7, scientific notation. And now it's asking you, how many significant figures do you want? Well, for these first 3 questions, we only wanted 3. So you hit the 3. Now, every number you type in there will be changed into scientific notation and 3 significant figures. So let's have a look at the question that we started with. 324 7,000. So 324 7 1 2 3. You hit equals, and it writes it in scientific notation for you. Let's try the other one. 0.001031. Now, the answer we should be getting is 1.03 times 10 to the power of something. And there it is, 1.03 times 10 to the power of -3. Now, if you wrote that answer or this answer, both would be correct. But if your calculator is going to do it for you, why not use it? Let's do the next one. 0.172046. 1.72 times 10 to the power of -1, which is the correct answer and is the same as this answer. So your calculator will do it for you. Now, let's go down to C. So if I get my calculator back, this time 4 significant figures. So I have to go and change the setup again. So I go Shift, Setup, Significant Scientific Notation, and I'm going 4. So just so I can check, the answer to this, if I wrote it in scientific notation, is 4.833. I'm going to move it 1, 2, 3, 4, 5, 6 times 10 to the power of 6. They are the same answer. Let's see if my calculator now does that. So 4.833 And there it is. The calculator does it. Watch, I'll do the next one because it's also 4 significant figures. 0.014427, and that should have been 1.443 times 10 to the power of negative 2. And it does it for you. Now, later on in this exercise, you need to do questions, and I'm only going to do one. Questions in scientific notation. So I'm going to do an easy one because they get quite complicated. So I'm going to do the first one here, which is D, and I'm just going to use my calculator. And this is all I want you to be able to do. So I'm going to have, it says in here, 4 significant figures. So that's great because my calculator is already set up to 4 significant figures. So let's just do the first one, 78 to the power of negative 3. And there's my answer. Lost it. 2.107 to the power of negative 2.107 times 10 to the power of negative 6. Now the next one, I'm going to type in a fraction. And I've got 3.185 over... Now here you've got an option. You'll see down on the bottom, underneath the number 3, you've got times 10 to the power. I don't actually like using that. I will do this question again using that, but I prefer to go 7 times 10, and I use my power button and get the 4 there. I just like that so much better. It looks better. It looks exactly like the question. And there I get my answer, 4.550. So 4.550 times 10 to the power, was it negative or positive 5? Negative 5. But I'm now going to do that question again using the other button. So I'm just going to go back. I'm going to delete this. And now I'm going to go 7, and I'm going to try that button down the bottom. Times 10, and now this is why I don't like it, because the power sits beside it like that. It doesn't appear high up, and it doesn't look like the question. But you can see I get the right answer. Let's do one more. I'll do the last one, and I'll do the first part using times 10 to the power, and I'll do the second part with that power button. So what have I got? 5.671 times 10 to the power of 2, and then I've got times 3.518. I'm going to go press that button down the bottom, and I'm going to put a 5. And again, yeah, I don't like it, but I still get the right answer. 1.995 times 10 to the power of 8. 1.995 times 10 to the power of 8. And that's all you've got to be able to do. Down here, they get really complicated, but you've got a calculator and you just have to type it in. You decide how you want to do. Notice in this one, you're going to have to reset your calculator to 5 significant figures, and that's all you've got to do. Good luck with that.